Quicksort is another approach to use divide and conquer technique for array sorting. This time we will do it in a different way than in the merge sort case. First we will select one element of our array. This might be, let's say, first element in the order, so in this case this will be 4. Okay, and we will try to transform this array in a way that all elements which are smaller than 4, so here this will be 2, 1 and 3, will end up on the left hand side of the array. Okay, and all elements that will be larger than 4, in our case this would be 6, 8, 7 and 10, and these elements will end up in the right hand side of an array. Alright, right now these elements do not have to be in a sorted order, but they just have to end up in the proper part of the array. So for example, after this transformation we can get the following situation. First 3 elements would be 2, 1 and 3. Then of course we will have number 4. We will call this element our pivot element. And later on the right hand side of this pivot we will have 6, 8, 7 and 10. Okay, we do not have a sorted array yet, but we can see certain properties. First of all, we can see that our pivot element, so 4 here, is already in its proper position. So in sorted array, the 4 would end up exactly where it is now. We do not have to change its position anymore. Now, what we have to do, we have to sort left hand side of the array, and we have to sort right hand side of the array. And interesting thing and very important thing is that we can do sorting of left hand side and right hand side independently. Okay, we do not have to transfer any numbers from the left side to the right side or from the right side to the left side. Okay, it's not necessary, they're already in the proper part, but we need to sort each of these parts. All right. So how can we do the sorting? Well, we can do it exactly as we did it before. We can select new pivots element for right hand side and the left hand side and transfer the elements smaller than the pivot and larger than the pivot in the proper parts. So let's see how this will work for the left hand side. Our new pivot element would be number 2. Okay, so now we want to have elements smaller than 2 on the left of the pivot and larger than 2 on the right. So what we should get is 1, 2 and 3. Okay, and then we will have our number 4. And now we know that 4 is already in its proper place and 2 is already in its proper place. Okay, now we will do all the shifts with the right hand side. So our new pivot will be 6. All elements that will be larger than 6 should end up on the right hand side and smaller on the left hand side. So this time there is no smaller element, so we won't be changing anything. So we will get 6, 8, 7 and 10 as we did before, but right now we know that 6 is also already in its proper position. Okay, so what we have to do now is we need to repeat our partitioning for the following subarrays. This one here that contains only 1, this one here that contains only 3, and this one here that contains 8, 7 and 10. Okay, the first 2 subarrays that contain only 1 element, they do not need to be sorted anymore. Okay, if array has 1 element, it's already in the sorted order. So we just rewrite it. 1, 2, 3, 4, and we know that each one of them is already in its proper position. Now 6 is the same, and we need to do the partitioning for this subarray that contains 8, 7 and 10. Okay, so we select another pivot, this will be 8 in this case, and after partitioning we will get 7, 8 and 10. Okay, we know that 8 is already in proper position and we need to do partitioning for this subarray and this subarray, but since they also contain only one single element, we can just leave them as they are. So in the end we get our sorted array. Now the only thing we need is our partitioning procedure. So how can we transform our array in a way that all elements that will be smaller than some pivot, here it will be 4, will be on the left hand side, and the elements larger than this pivot will be on the right hand side. And this is how we can do it. Okay, so first let's rewrite our array just as it is. Okay, and we will split it into 4 parts. First part will be our pivot element, okay, and it ends up here. The other 3 parts will contain elements that we know that are smaller than the pivot, elements that we know that are larger than the pivot, and the final part will have elements that we do not know in which part there should land up. Okay, so first, since we don't know anything, all other elements will be in this last region. Okay, so if we will just mark somehow where our first and second regions ends, we can use or do something like that. Okay, let's say that blue line will indicate where elements that are smaller than the pivot ends, and the orange one, it will indicate where elements that are larger than our pivot ends up. Okay, so now what we were gonna do is to swap elements from the array and expand these 2 regions. Here is how it works. So first we take the last element, it will be element number 10, okay, and we check if it's smaller or larger than the pivot. 10 is larger than 4, so it should land up on the right hand side. So what we see is that we do not have to change position of 10, and we can shift indication of our larger elements region by 1 position. Okay, now it's here. And now the next element would be 7. 7 is also larger than 4, so we also do not have to change its position, and we can move indicator of our region. Okay, next element is 8, also larger than 4, so again we just shift the mark of our region. And now we get to 3. Okay, this time we have different situation because 3 is smaller than our pivot, so it's smaller than 4. So what we want to do is we will swap 3 with the first element close to the blue line. Okay, so we will swap 3 with 2. Okay, let's do it right now. Okay, and now what we know is that 3 is already in the proper position. Okay, it's in the region that should contain numbers smaller than pivot. So we can shift mark of this region. And now we go back to this element here. Okay, this time it's 2. 2 is also smaller than 4, so again we do the swap. This time the first element on the right hand side of our blue line is 1. So we swap 1 and 2. Okay, and we can expand left hand side region. We go back to this element here, it's 1. Again, we have to do the swap. We expand the blue region. And now we end up with final element, which is 6. Okay. So this time we do not do the swapping. 6 is larger than 4, so we expand the orange region. And now we see that the blue line and the orange line is in the same place. Okay, so our 2 regions they met, so it means that we do not have the region containing elements that we do not know where they belong. Now we have to do just one more thing, which is to position the pivot in its proper place. Okay, so we need to swap 4 and 1. And now we have our proper partitioning. It means that we have our pivot in its proper position, where we will end up in the sorted array, and all elements on the right hand side are smaller than the pivot, and all elements on the right hand side are greater than the pivot. Okay, and now, as you know, to do the sorting we can repeat this partitioning procedure for both left hand side and right hand side subarrays.